All right, in this video we are going to be talking about protecting groups. So sometimes with Grignards, protecting groups are necessary in order to ensure that the Grignard reacts with the part of the molecule that we're interested in, such as the ketone, aldehyde, ester, acid chloride, anything of that sort, basically the carbonyl carbon. However, if there is something such as like an alcohol present or any sort of NH or OH bonds, the Grignard is going to react with that, resulting in deprotonation. So in order to keep bonds such as OH and NH from reacting with the basic reagents or our Grignards, we can add a protecting group. One of these protecting groups is a TBDMS group, which is going to protect alcohols. So as you can see, we have an alcohol in our problem that we are working with right here. So that would be a good protecting group to use in this instance. Up at the top, you can see that without a protecting group, we would just deprotonate that alcohol, form methane. That's not really what we want to do though. We're more interested in that Grignard reacting with the ketone. So how can we do this? We're going to first add TBDMSCl, which is just a special type of protecting group. So what that is going to do is that is going to essentially replace the proton of our alcohol group, allowing us to go through and do our Grignard reaction. Looks like we have methyl Grignard here. And our second step is water. It's going to allow us to have an alcohol form instead of just deprotonating that alcohol when we add the Grignard. Now, in order to get rid of our protecting group for TBDMS specifically, we are going to use something called TBAF, just TBAF. And what that is going to do is that is going to restore our original alcohol group, leaving us with that alcohol group, or with that product that has two alcohol groups on it. All right, so here we have a practice problem. I suggest predicting the product if you did not have a protecting group, then predict them with the protecting group, and then work your way through that mechanism, showing the addition of the TBDMSCl and the TBAF when appropriate. And I will have answers posted for you to check against your work. So thank you for watching. All right, so here is what you should have gotten. That product on the bottom shows what you would have gotten if you did not use a protecting group when reacting this starting material with a Grignard, and the product up on top on the right indicates the product that we ideally would get with the use of a protecting group.